Alright, so far we have factored in the box, right? We factored a difference of two squares, right? What's the other pattern we factored? Perfect square trinomial. So today I'm going to show you some other methods in factoring, okay? And this will be the last of it for a while. But you'll have to pull from this point forward, okay? So make sure you pay attention. All right, first of all, you're going to be doing what we call factoring completely. Completely. Okay? Now, what that means is, I'm going to start out with something that I tell you to factor. Can you factor that? Sure. It's a special pattern. What pattern is it? Trinomial means three pieces. These are both perfect squares.
Oh my God.
How many squares do you see? You're right. Two. What sign's in the middle? What's another word for subtraction? Or what's another difference? I have a difference of two squares. How does it factor?
X squared
Minus
4 squared.
And, ooh, we need to go brush up on our factoring patterns. When it's a difference of two squares, it's 1 plus 1 minus. Perfect square trinomial does the same sign twice. Okay? It's an easier factor. Now, factoring completely means once it's factored, you look at the factored pieces and see if you can factor again. Keep factoring.
Were you teaching your kid long division?
Until you can't. No, I thought that's what we were doing today. And I reference a long division problem as I teach y'all polynomial long division. I got mixed up. It's tomorrow. We'll do it tomorrow.
Miss McGee, what
All
are
right.
you going to do with your stomach?
So looking at these two pieces, do you see anything else that I can do?
Square the 4 with the square.
I see another. Look at this. If this is a difference of two squares, guys, pay attention. This is also a difference of two squares. Do you see that?
Yes.
Two perfect squares separated by a subtraction sign. How do you break that down? X minus 2, X plus 2. Can I do that one also? It's not a difference. It has to be a difference. Okay? So that one stays. So at this point, this is factored completely. Because none of the pieces that are in there now can be factored any further.
How do you write the x squared plus 4?
Because it can't be factored any further.
It's like super simple. What?
Yes.
Well, then the x squared minus 4 couldn't be factored in either, right?
It can't, no. It can't because it's a plus.
Why don't you write it if you're writing the x squared plus 4?
Do what?
You wrote the x squared plus 4. Why?
Another one. Remember the steps in factoring as we go. The first thing is to check for what?
C.
What's your first step in factoring?
Check for GCF.
Check for a GCF, okay? Check to see if it follows a pattern, a difference of two squares, or a perfect square trinomial, or the other patterns that I'm going to show you today. And then if those fail, can you put it in the box?
Yes.
All right, so here, all my directions say is factored completely. Yes.
Do you have a categorization?
Possibly do you need it right this second? So if I take out a 2y to the third, it leaves me with y squared minus 9.
Oh, see, I did that wrong on the quiz.
You didn't have that on the quiz we just took.
Oh.
Wait,
Maybe he just did it right.
No, it's a homework.
Okay, okay.
you just simplify it.
So now the question is,
Wait, we're
since, okay.
It goes backwards.
All right, so we're back to 1314.
And why did you change change the decimal, I mean, thing from 2 to
When you have a GCF, a greatest common factor, you divide the coefficient into everything and take it out, and you take out as many of the variable as you can. Okay? All right, now looking at what's left, because the new part now is looking at what I had and then going back to say, okay, now the parentheses, is there anything that I can do? Sure there is. What do you see? Yes, it's another difference of 2 squares. So the 2y cubed stays. This becomes y minus 3, y plus 3. Does that make sense to everybody? Okay.
That part does. I'm kind of confused about how you went from the first step to the second bit. Just because.
Taking that GCF out.
And what the GCF is 2y.
Right. So the coefficient's the biggest thing you can divide both
And then
coefficients
the third
by.
is the biggest coefficient.
Yes, yeah, the biggest exponent you can take out. All right. Yes, you're just, so there's nothing new here. There, other than you're doing it again and again and again until you can't anymore. Okay? Yes? All right. Chapter 1 concept other than continuing to break down the parentheses. Now, I want to show you something called quadratic form that you will be able to factor in, okay? Now, the reason I like the box so much, and I've shown you the box, is because it works in all these forms. If it's in quadratic form, you can factor it. So here's what quadratic form means. Quadratic form means I have 3 terms, okay? I'm going to call this AX, BX, AX to the, this exponent here, if this is an even number, and the exponent in the middle is half of the first exponent, okay? Then you can put it in, and this is a constant. That is called quadratic form, and you can put it in the box to factor it. Okay? So let me show you an example of what I'm talking about. And again, once we get these pieces factored, you're still going to have to look to see if you can break it down any further and factor it further. What are y'all laughing at?
I'm just laughing at Ben's laugh.
Let's look at this one. 4x to the 6th minus 20x to the 4th plus 24x squared. So my question to you is, can we factor that? What's the first step in factoring? What should I always ask myself first?
The GCF.
The GCF.
Yeah. X,
Okay.
You can take 4x.
Take 4x
To the 4th.
to the second. What's left if you take that out?
X to the 4th minus 5x squared plus 6.
You're a genius.
Ooh, well, yeah. That was
Divided all the coefficients by the coefficient. Yep. And now, you're right, Drew, it looks like that new thing. Now it's in quadratic form. This is even, this is half of that, and this is a constant.
Wait, so. Oh, no, I got that.
Okay, now watch how this works, because if you understood the box, this will make perfect sense. What are my signs going to look like? Both negative, so I don't have to keep up with signs, right? First term, first box. Last term, last box. What multiplies to 6x to the 4th but adds to 5x squared?
-1.
Same signs. Same signs. Same signs.
2 and 3.
2 and 3.
2 and 3.
Same signs. Look, now watch. Watch. Think about how we add and think about how we multiply. It's got to multiply to 6x to the 4th, but add to a power of 2. So 3x squared and 2x squared, those are like terms, right? If we add them, we get 5x squared. If we multiply them, we get 6x to the fourth because we have to add the exponents. Okay? So 3x squared, guys. Same concept exactly. Except, right. Except before, this was a 2 and this was a 1 because it was a quadratic. Now it's a quadratic form, but it's not exactly a quadratic. All right, let's go up and over. What's the GCF here?
When are we doing our videos?
So, no, I don't know.
Correct.
X squared. How about here?
That one's 2.
2. Okay, how'd you get x squared? GCF, the biggest thing that you can take away from both of them with no remainder, or divide both of them. Yeah. All right, across, what's the GCF? X squared, and the GCF? 3. Okay? Exactly. Now, be careful because I need to check again, right? Factoring completely is every time you factor, you look to see if you can do it again. Can I do it again? No. Why? Neither of those two are perfect squares. So this is factored completely. Does that make sense? Y'all want to do one more?
Yeah, let's do one on our own and see if we can get it.
So is it just the same thing as the old one?
I think I can figure this out.
Not a whole lot of times. I mean, but you'll keep going until you can't anymore.
Can we do one on our own?
Okay, here, try this one. 2x to the 8th. Guys, I feel like I'm fighting y'all, and I feel like the ones that I am fighting are the ones who don't even have a really good grasp on factoring. Plus 12x squared. Try. All right, let's look at this one together because we've got 3 more forms to look at. If you take the GCF out, what is the GCF here? 2x squared. What is left when I factor out the GCF of 2x squared here? X to the 6th plus. Now, so the question becomes, looking at the piece that I have left, can I factor that further? Well, the only way I can factor a trinomial like this is if 1, it's a perfect square trinomial, or 2, I can put it in the box. So could I, it's not a perfect square trinomial because 6 is not a perfect square. Can I put it in the box?
You can do it again,
Yeah.
Even, half, constant.
What do you
Okay.
do about it?
It's not too hard.
Put it in the box.
Yeah, I know, but
So x to the 6th and 6th, signs are going to be the same. They're both plus, right?
2x squared and 3x squared.
What multiplies to 6x to the 6th but adds to 5x to the 3rd? 2x to the 3rd and 3x to the 3rd. Okay? This is going to be the exponent of your remaining boxes each time. 2x cubed, 3x cubed. Now go up and over. What's the GCF here? X3. How about here? 3. How about here? X3. And how about here? 2. So the 2x squared still sits. I've got x cubed plus 3. X cubed plus 2. All right. Next pattern. Trying to think if we should do grouping or what time is it? What time's that clock say?
9:29.
Okay. Let's do the sum or difference of 2 cubes. Okay. Now, first of all, what is a cube?
It's to the third.
To the 3rd power. Give me some examples of perfect cubes.
4 squared.
4 cubed, which would be what?
3.
What's 4 cubed?
2.
Come on, guys. What's 4 times 4 times 4? 64. Give me another perfect cube. 3 cubed. What is 3 cubed? 27. Surprise, you're going to have to start being able to recognize these. Wait. Give me another perfect cube.
9.
6 cubed.
Which would be 216. Give me another one.
Wait, why? What is every number a perfect cube?
Every number to the third power is a perfect cube.
9.
Which is 8. 8 is a perfect cube.
9.
Yes, yes.
9 perfect cube.
All right, let me show you a list here.
There's a lot less.
2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third is 216. You need to be able to recognize at least through there. Minimum.
Oh, wait, what?
Okay, you know how I gave you the list of perfect squares and said you need to be able to recognize these? Perfect cubes, you need to be able to recognize at least that many, okay? Now, the difference in this one is, if you look the sheet I just gave you, the first one is difference of 2 squares. That was chapter 1, right?
Yes.
Second one's perfect square trinomial, again back to chapter 1. Now we're adding 3 through 5, all right? And 3 and 4, I kind of lumped together. Now there is no way, I'll tell you before I show you this, there's no way to do this other than to memorize this pattern, okay? I'll try to make it as easy as I can for you. If I start with 2 perfect cubes, let's say x to the third and 8. And I'll do one as a sum and one as a difference. Now, be very careful because remember, squares are only difference, but cubes can be sum or difference, okay? To factor this, you set up 2 sets of parentheses, a little and a big. You set your signs up first. Your signs go same, change, plus, always plus. Okay, same, change, plus, every single time. So down here, if it was a difference of 2 cubes, it would be minus, plus, plus. Same, change, plus. You're going to fill out the little parenthesis first, okay? What times itself 3 times gives you x to the third? X. What times itself 3 times gives you 8? 2. Okay? Now we're going to use that to fill in the rest. Square the first one. What do you get when you square this? X squared. It goes in the first spot. The last one squared goes in the last spot. 4. And the middle is a combination of them, so you multiply them together. 2x. The first 2. Always looking back at the first 2. Okay? It's just a pattern that you just have to memorize. This is the same thing. These will be the same numbers. The signs are just different. Okay? But I can do sum of 2 cubes or difference of 2 cubes. Oh, let me show you an example. All I'm asked to do is to factor this completely. Okay? So recognize, automatically I see the 8 and 27 and I'm thinking cubes. Okay? Sum of 2 cubes, do we all agree? All right, so set up your parentheses first. Small, big. What are my signs going to look like?
Plus, change, plus.
Same, change, plus.
Same,
Same, change, plus. What times itself 3 times gives you 8x cubed? 2x. What times itself 3 times gives you 27? Is anybody confused on the first set of parentheses? Okay? First one squared goes in the first spot. What's What do you get if you square the 2x? 4x squared. Last one squared goes in the last spot. 9. What goes in the middle? Together, 6x, yes.
Wait, how you do the middle one again?
Multiply the 2x and the 3x together. Okay, it's just a pattern, but you have to practice with it so it clicks, okay? All right, y'all ready to group?
Let's do one more.
One more? Now remember, I keep saying this, cubes can be plus or minus, squares can only be minus the factor, okay? Look at your sheet, it's a difference of 2 squares, not a sum of 2 squares. Yes. Let's do... Together. It's difference of 2 cubes, little parenthesis, big parenthesis, same change plus. What goes in the first spot? 6x. How about the second spot? 1. Square the first one to go in the first spot and you get 36x squared. You times 2. Square the last one to go in the last spot. Multiply together. Don't worry about signs because you took care of signs in the beginning when you did same change plus.
Okay, so wait. So to get the first number, you do what?
Try writing it like this. Try writing 216x cubed minus 1 as 6x cubed minus 1 cubed. What times itself 3 times gives you 216? That goes back to this list.
6 times 6 is 36 times 6 is 216.
Yes.
Just have to know.
Where did you get thrown off on that one? Nowhere. The what? The signs. So you have to just memorize same change plus. Same change plus.
And you don't have to worry
Same
about
change
even
plus.
if it's negative.
Yeah, even, right, because I think that's what you were doing. When you multiply these two, don't carry the sign with it. It's just 6 times 1. All right, one more thing to show you. I know y'all are so excited. This is the one that I saved it for last because it's generally the easiest for everybody. Because it makes sense. It's not something you have to memorize to do. You look at it, it makes sense, it follows, okay? It's GCFing it to death. That doesn't sound nice. It's taking the GCF over and over and over. All right, so grouping problems have 4 pieces to them, okay? So x to the third minus 3x squared minus 16x plus 48. So here's what you do with 4 pieces. I call these slashing problems because you're going to look at this as 2 different problems. Okay. The first 2, yeah, the sign's going to follow the second half. Okay, so make sure you do it that way. Look at the first 2. Is there a GCF there?
No.
Just the first 2. Yeah,
Well,
what is it?
X squared.
X squared. Take the GCF out of just the first 2, what's left?
X minus 3.
Okay, y'all following me? Now look just at the second 2. Do they have a GCF?
Yeah.
Yes, what's the GCF? 16. Now remember, I got to take this minus, so what I'm really doing is I'm taking a negative 16 out of both. So what's left? X minus 3, because if I'm taking a negative 16 out, I have to change the sign. So if the middle sign is negative, it changes the last sign. Now, what do you notice now coming back to look at this as a whole? What do you notice they now have in common?
X minus 3.
X minus 3. Do we see that? Now think about how you take a GCF out. When you take a GCF out, you take it out of both of them, right? And then you write what's left. So what if I let x minus 3 be my GCF? Take that out of both of them and write what's left. That's factor by grouping. Do you see what I did? Where did the what?
48.
Because I took a 16 out of both of them. So I divided it by negative 16.
Oh, now I'm getting to
I don't understand.
Yeah, I don't understand. But wait, hold on.
What's what?
What's in blue?
Okay. You see how you took an x squared out of both of these? Right? I wrote it on the outside. Even though I took it out of both of them, I wrote it one time on the outside, and then I wrote what was left. Okay? When I get to this in white, I take an x minus 3 out of both of them. That acts like my GCF. And then I write what's left. If I take an x minus 3 away from this, I'm left with x squared. If I take an x minus 3 from here, I'm left with 16. Does that make sense to everybody?
Yes.
Can I factor it any further? Do you see it? Several of you are going, I see it. What do you see?
Perfect. Difference of 2 squares.
Difference of 2 squares. How does difference of 2 squares factor?
It goes x minus 4 times x plus 4. Wait,
Now you are done. Let's do another grouping. Once none of the parentheses factor any further, you're done and you stop. Well, the x is not squared, so the x is not a perfect square. Okay, both of them have to be perfect squares. Let's do another one. Let me see. Let me find one that's going to work nice. Let's do this one. This one comes from your homework, so make sure you write it down. X cubed minus 7x squared plus 4x minus 28. So remember, I'm not always going to tell you, hey, factor this by grouping. It's just going to say factor completely. So what clues you in is there's 4 pieces. I don't know any other way to factor a 4-piece polynomial other than to slash it. Okay? So, slash it. And I put it backwards there. Come on. What can you take out of the first 2? An x squared. What's left? Will somebody pick that up? Ben, will you pick that up, please? What's left in the first 2 if I take an x squared out? X minus 7.
Hey, William. Wait, you want me to tell him to go to the office? Okay, guys. William, do the guidance box.
Probably won't take stuff. It's about time for the bell ring. All right, look at the second 2. Can you take anything out of the second 2 of 4? Okay.
My IGP got canceled because Mr. Cooper had the flu. When will I think?
They'll still call you. They'll call
I know,
you.
but like.
I don't know.
Have to wait till everything goes.
I don't know. All right, what's left? X minus 7.
We do?
And then you take that 7 out.
Now, exactly. Now, because now if these 2 aren't the same, it won't group. But these 2 are exactly the same, sign and everything, so I take it out of both of them, write it one time. If I take it away from both, what's left?
Oh, that's pretty easy. I get it.
Now, can I factor x squared plus 4 any further?
No.
No, because it's a sum of 2 squares, not a difference of 2 squares. Yes.
Wait, what? You can't factor x squared